All right, so now you get to learn a little bit of a few of the shortcuts for proving triangles are congruent. And the first two shortcuts you're going to learn today are SSS, which stands for side, 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 and SAS, which stands for side, angle, side. So our objective today is to apply SSS and SAS to solve problems and also to prove that triangles are congruent using SSS and SAS. So a few vocabulary terms first. Triangle rigidity gives you that shortcut for proving that triangles are congruent. So if the side lengths are given to you, then triangles can only have one shape. So an angle formed by two adjacent sides of a polygon is called an included angle. And in my picture here, I could say that angle A is included, so angle A is the included angle for sides AB and side AC. Okay, so angle A is the included angle for the two sides that are adjacent to angle A. So you're going to need that vocab when we do one of our shortcuts. So our first shortcut is here, the side, side, side congruence. And it says that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent to each other. Okay, so if I am told that side AB is equal to side DE, and side AC is equal to side DF, and side BC is equal to side FE, then that's all you need to prove that triangles are congruent. You no longer have to have all three sides and all three angles. Just all three sides is enough. So if I have this information, then I know that triangle ABC is congruent to triangle DEF. Okay, so that's one shortcut. The other shortcut is SAS, that you're learning today is SAS, and it says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent to each other. So this says if two sides, so if we say A, B, and DE is congruent to BC and FE, and also their included angle, so that would be angle B and angle E. If that's true, then I know that triangle ABC is congruent to triangle DEF because of side, angle, side. So that is another shortcut for you. You no longer need all the sides and all the angles. You only need the two sides and then the included angle of one to be congruent to two sides and the included angle of another. So let's go ahead and write out a proof. So here's, we're not going to do this top one, but I do want to do a proof with you. And so here's our proof. Let's see what we're going to be doing on this proof. So we want to prove that the two triangles are congruent. So this triangle is congruent to this triangle. Let's see what we're given. Here's what we're given. We're given that AB is congruent to CD. We're also given that AD is congruent to CB. Okay, and if you look at the picture, you can see something that's obvious from the picture, which is that BD is shared by both triangles. Okay, so if I look at this, I see that my plan should be side, side, side. You only know of two shortcuts right now. That's side, 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 and side, angle, side. And this one's going to be side, 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 because there are no angles that were given, and there's no angles that we can pull from this picture easily. Okay, so then let's go ahead and start writing our proof. So now that we have our plan, so I'm going to go ahead and write my given. And you'll notice that I already have two sides done. So I have a side and a side. So I'm going to go ahead and cross those off of my plan because I've already done two of them. Now I just need to write the third one. So the third one is the one that they share. So that would be BD is congruent to BD. And if you remember from the previous chapter, that's the reflexive property. So now I have my third side, and so I can cross that off. So I've done all three sides. I've finished my plan, which means I can go ahead and go straight to the proof statement. Triangle ABD is congruent to triangle CDB. And my reason is my plan. Okay, my reason is my plan, side, side, side. Oops, this should be 3. Okay, so there we have it. We've just proven the two triangles are congruent by side, side, side. And that's how easy it is.